We already know that the sum of the interior angles of a triangle add up to 180 degrees. So if the measure of this angle is A, the measure of this angle over here is B, and the measure of this angle is C, we know that A plus B plus C is equal to 180 degrees. But what happens when we have polygons with more than 3 sides? So let's try the case where we have a 4-sided polygon, a quadrilateral. And I'm going to make it irregular, just to show that whatever we do here, probably it applies to any quadrilateral with 4 sides, not just things that have right angles and parallel lines and all the rest. And actually, that looks a little bit too close to being parallel, so let me draw it like this. Let me draw it like this. So the way you can think about it with a 4-sided quadrilateral is, well, we already know about this. The measures of the interior angles of a triangle add up to 180. So maybe we can divide this into 2 triangles. So from this point right over here, if we draw a line like this, we've divided it into 2 triangles. And so if the measure of this angle is A, measure of this is B, measure of that is C, we know that A plus B plus C is equal to 180 degrees. And then if we call this over here X, this over here Y, and that Z, those are the measures of those angles, we know that X plus Y plus Z is equal to 180 degrees. And so if we want the measure of the sum of all of the interior angles, that's going to be, all of the interior angles are going to be B plus Z, that's 2 of the interior angles of this polygon, plus this angle, which is just going to be A plus X, plus A plus X. A plus X is that whole angle, the whole angle for the quadrilateral, plus this whole angle, which is going to be C plus Y. C plus Y. And we already know A plus B plus C is 180 degrees. A plus B plus C is 180 degrees. And we know that Z plus X plus Y is equal to 180 degrees. So plus 180 degrees, which is equal to 360 degrees. So I think you see the general idea here. We just have to figure out how many triangles we can divide something into, and then we just multiply by 180 degrees, since each of those triangles will have 180 degrees. Let's do one more particular example, and then we'll try to do a general version. We're just trying to figure out how many triangles can we fit into that thing. So let me draw an irregular pentagon. So 1, 2, 3, 4, 5. So it looks like a little bit of a sideways house there. Once again, we can draw our triangles inside of this pentagon. So that would be one triangle there. That would be another triangle. So I'm able to draw 3 non-overlapping triangles that perfectly cover this pentagon. This is one triangle, the other triangle, and the other one. And we know each of those will have 180 degrees if we take the sum of their angles. And we also know that the sum of all of those interior angles are equal to the sum of the interior angles of the polygon as a whole. And to see that, clearly this interior angle is one of the angles of the polygon. This is as well. But when you take the sum of this one and this one, then you're going to get that whole interior angle of the polygon. When you take the sum of that one and that one, you get that entire one. And then when you take the sum of that one plus that one plus that one, you get that entire interior angle. So if you take the sum of all of the interior angles of all of these triangles, you're actually just finding the sum of all of the interior angles of the polygon. So in this case, you have 1, 2, 3 triangles. So 3 times 180 degrees is equal to what? 300 plus 240 is equal to 540 degrees. Now let's generalize it. And to generalize it, let's realize that just to get our first 2 triangles, we have to use up 4 sides. We have to use up all the 4 sides in this quadrilateral. We had to use up 4 of the 5 sides right here in this pentagon. 1, 2, and then 3, 4. So 4 sides give you 2 triangles, and it seems like maybe every incremental side you have after that, you can get another triangle out of it. Let's experiment with a hexagon. And I'm just going to try to see how many triangles I get out of it. So 1, 2, 3, 4, 5, 6 sides. And I can get one triangle. I get one triangle out of these 2 sides. 2 sides of the actual hexagon. I can get another triangle out of these 2 sides of the actual hexagon. And it looks like I can get another triangle out of each of the remaining sides. So 1 out of that one, and then 1 out of that one right over there. So in general, it seems like, let's say that I have S-sided polygon. S-sided polygon. And I'll just assume we already saw the case for 5 sides, or 4 sides, 5 sides, or 6 sides. So we can assume that S is greater than 4 sides. Let's say I have an S-sided polygon, and I want to figure out how many triangles, non-overlapping triangles that perfectly cover that polygon. How many can I fit inside of it? And then I just have to multiply the number of triangles times 180 degrees to figure out what are the sum of the interior angles of that polygon. So let's figure out the number of triangles as a function of the number of sides. So once again, 2 of the sides, or 4 of the sides, are going to be used to make 2 triangles. So there's 2 sides right over there, and then maybe we have 2 sides right over there. I can draw 1 triangle over, and I'm not even going to talk about what happens on the rest of the sides of the polygon. You can imagine putting a big black piece of construction paper. There might be other sides here. I'm not even going to worry about them right now. So out of these 2 sides, I can draw 1 triangle just like that. Out of these 2 sides, I can draw another triangle right over there. So 4 sides used for 2 triangles. And then no matter how many sides I have left over, so I've already used 4 of the sides, but after that, if I have all sorts of craziness here, I could have all sorts of craziness here. So let me draw it a little bit neater than that. So I could have all sorts of craziness right over here. It looks like every other incremental side I can get another triangle out of it. So that's 1 triangle out of there, 1 triangle out of that side, 1 triangle out of that side, 1 triangle out of that side, and then 1 triangle out of this side. So for example, this figure that I've drawn is a very irregular 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a decagon. And in this decagon, 4 of the sides were used for 2 triangles. So I got 2 triangles out of 4 of the sides. And then out of the other 6 sides, I was able to get a triangle each. These are 6. This is 1, 2, 3, 4, 5. Actually, let me make sure I'm counting the number of sides right. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me make sure. Did I count? Am I just not seeing something? Oh, I see. I actually didn't. I have to draw another line right over here. These are 2 different sides. So I have to draw another line right over here. I can get another triangle out of that right over there. And so there you have it. I have these 2 triangles out of 4 sides. And then out of the other 6 remaining sides, I get a triangle each. So plus 6 triangles, I got a total of 8 triangles. And so we can generally think about it. The first 4 sides, we're going to get 2 triangles. So let me write this down. So our number of triangles is going to be equal to 2. And then I've already used 4 sides, so the remaining sides I get a triangle each. So the remaining sides are going to be S minus 4. So the number of triangles are going to be 2 plus S minus 4. 2 plus S minus 4 is just S minus 2. So if I have an S-sided polygon, and if I have an S-sided polygon, I can get S minus 2 triangles that perfectly cover that polygon and they don't overlap with each other. Which tells us that an S-sided polygon, if it has S minus 2 triangles, that the interior angles in it are going to be S minus 2 times 180 degrees. Which is a pretty cool result. So if someone told you that they had a 102-sided polygon, 102 sides, so S is equal to 102 sides. You can say, okay, the number of interior angles are going to be 102 minus 2. So it's going to be 100 times 180 degrees, which is equal to 180 with 2 more zeros behind it. So it would be 18,000 degrees for the interior angles of a 102-sided polygon.